Hello friends, welcome to my channel Maths Realization. So today we are going to learn about the questions related to indices. So let's start our class. So let's start our question. So here the first question is seen like this. Okay, so here on your screen you can see the question. The question says x cube plus y cube plus z cube equal to 1. Okay, so this is the given part. If means this is the given part, and so that you have to show this a to the power x upon a to the power minus y whole to the power x square minus xy plus y square times a to the power y upon a to the power minus z whole y square minus yz plus z square times a to the power z upon a to the power minus x whole z square minus zx plus x square equal to a square. So you have to show this LHS is equal to RHS, and you have to solve LHS and you have to find its value is a square. Okay, so let's start our solution. So in this type of question, what we have to do is, first I will write the question here. LHS, I have written here LHS, left hand side. This part is left hand side, left to the equal to and right to the equal to is right hand side. So I am taking LHS. So here first we are going to solve this part. Okay, we are going to solve this part. To solve this part, to solve this inside the bracket part, we have to know this formula, as I have made already a video on laws of indices. So try to watch that video. So here a to the power m upon a to the power n, this formula says when we take this denominator on the numerator, this whole denominator on the numerator, the base becomes basis, because base is same, so we only have to subtract the powers as n goes on numerator, power n goes on numerator, and its sign is changed. Its sign is here positive, its sign becomes negative when it goes to upside, or if its sign is negative, when it moves on the numerator its sign becomes positive. So we have to just change the sign of the power of the denominator when we take it on the numerator. Okay, so we are using this formula here on these three steps and on these three, and now it is seen like this. Okay, so when we take minus y on the numerator it becomes plus y, when we take minus z on numerator it becomes plus z here, and when we take minus x on numerator it becomes plus x. Now you know the formula like this. If a to the power is m and whole power is n, then what we have to do, we have to multiply the powers. We have to multiply only the powers. Okay, so similarly here m x plus y, x as m, and this part x square minus xy plus y square x as n. So then what we get here also it is like this. We have to use this formula. Then you get like this. You have to multiply x plus y times this, similarly y plus z times this part, and z plus x times this power part. Okay, now to solve this we have to know the formula of a cube plus b cube. So the formula for a cube plus b cube is a plus b times a square minus ab plus b square. Okay, so this is the a cube plus b cube equal to a plus b times a square minus ab plus b square. So you have to use this formula here on these three powers. Okay, here and here. So let's use it. It's seen like this. Okay, so it is in the form this x as a, x as a, and here a, and y x as b. If you compare these two parts, this part and this part, you will get a cube plus b cube. So here is the formula for this is x cube plus y cube. Similarly, when we compare this with this formula, you will get y cube plus z cube, and when you compare this with this part, you will get z cube plus x cube. Now, as you know, if the bases are same and whatever the powers is, you have to add the powers. So here a base a power times base a power times base a power something is there. So you have to just add the powers. Add the powers like this: x cube plus, this is x cube plus y cube plus y cube plus z cube plus z cube plus x cube. So you can add, you have to add the powers. Now when you add this, there is x cube and x cube, so it becomes 2x cube. As we have seen in my previous video, you have to add the like terms that have same variable and same power. So x cube and x cube are added. When we add, this variable remains same and their coefficients is added. So here is coefficient 1, here is also coefficient 1, so it becomes 2. Similarly, y cube plus y cube, 2y cube, and z cube plus z cube is 2z cube. Then what we will do, we have to take out the 2 common, because 2 is in this part or in this term also, and in this term there is 2, so we have to take out 2. So the remaining is x cube plus y cube plus z cube inside the bracket, and we have to use here, we have given x cube plus y cube plus z cube equal to 1, so we will use it here as a to the power 2 times 1. I have written x cube plus y cube plus z cube as 1 because it is the given part. Okay, so it's your answer. So power 2 times 1 is a to the power 2 or a square. This question is this much, so let's move on. Question number 2. So question number 2 is seen like this. Here a plus b plus c equal to 0 is given. If part is the given part, and you have to show this LHS is equal to 1. Okay, so 1 plus x to the 1 upon 1 plus x to the power a plus x to the power minus b plus 1 upon 1 plus x to the power b plus x to the power minus c plus 1 upon 1 plus x to the power c plus x to the power minus a equal to 1. So you have to solve this LHS and you have to show its value is 1. So in this type of question, here before solving it, I will give you a tip here. First you have to make the denominators of these 3 terms. There are 3 terms. This is first term, this plus and plus separates the terms. So this is first term, this is second term, and this is third term. So you have to make the denominators of all the terms equal, otherwise it's difficult for you to solve it. So before taking the LCM, you have to make their denominators equal. So to make their denominator equal, okay, let's make their denominator equals first. So we are going to use this formula here: a to the power n equal to 1 upon a to the power minus n. So this is power law, and when we, this is in the numerator part because it has denominator 1. So if there is no denominator, then you can assume it as 1. If you take it in the denominator, then what you have to do, you have to change the sign of the power only, not the variable or base. A is the base, n is the power. You have to change the sign of power only. And another is a to the power minus n. A to the power minus n, it is also denominator 1, and when we take it in the denominator, then we can write it as a to the power n. We just have to change the sign of this power. So here is minus, here is, we have to change it to plus n. Okay, now we are going to use this formula. So we just have to write x to the power minus b equal to 1 by x to the power b as this formula. Okay, so similarly here also, and similarly here also, we have used this formula. So now we have to take the LCM of the denominator only, not the whole part. We are taking the LCM in the denominator only. So the LCM here is, they have denominator 1, this x to the power a have also denominator 1, and this 1 have denominator x to the power b. So we have to take the x to the power b as denominator. Before taking the denominator as LCM, I will show you how to take the LCM. As this is in this form, a by b plus c by d form, then what you have to do, you have to multiply these denominators b times d, and what is not here in b but it is in the LCM. So d is in the LCM but not here, so we have to multiply by d with a on the numerator. So what is not here? B is not here in the denominator, but b is here in LCM, so we have to multiply on the numerator with b. The part that is not in the denominator but it is in the LCM, you have to multiply that part in the numerator. Okay, like that. So here we have done same thing. So here is denominator 1, so we have to multiply with xb. Here also we have to multiply with xb, but here is denominator 1 and the LCM is also xb, so we don't have to multiply anything. Similarly for these two terms I have done here. Okay, so after that use some formula here. The formula like a by b whole upon c by d. So this is in this form, a by d divided by c by d. When we change this divide into multiply form, you will get like this. You have to, the denominator, the division part when written in the multiply form, the places of denominator and numerator is exchange. So denominator moves to upside and numerator moves to the lower side or in the denominator part. So here I have done same thing. This xb is in the form of c by d. This is c part, this is d part, so this part moves on the numerator here on the top. When we multiply 1 by 1 times x to the power b by this part is c, this part x as c and this part x as d, because this is the division, this is this division. So when we change it into multiply, so 1 times x to the power b moves on upside and this is on the lower side. And I have used another formula here, yeah, this one. So when x to the power a times x to the power b, they have same base, isn't it? Same base, so we have to add the powers by this formula. Same base, just add the powers. So times a plus b, x to the power a plus b. Similarly here also you have to do the same thing, and here also you have to do the same thing. Okay, now what you have to do is, all the denominators are in different form. There is nothing equal here. See, no denominators are equal, so we have to make the denominators of the terms, this term and this term equal. To make these equal, first multiply with a variable in only one term. So I am multiplying here in this first term. So what I have done here, I am multiplying the numerator and denominator of first term by x to the power c, because if you check on the denominator, you see a plus b, but there is no x to the power c. So we are using three variables, x to the power a, x to the power b, x to the power c. So there is no x to the power c in this term, so we have to multiply this term with, on the numerator with x to the power c, and on the denominator also. So denominator, when you multiply with the denominator, it goes with every term, here also, and with 1 also here. Okay, and we don't have to do anything right now on this part. Now after multiplying with x to the power c, the equation is like this. So we have to use the same formula here, a to the power n times a to the power m, isn't it? So a to the power n times a to the power m is, powers are added because base is same, then you have to add the, when it is in multiply form, then powers have to be added. So just I have added the power on the top and on the denominator also. So these have same variables, sorry, same bases, and we have to add the power a plus b plus c here, and 1 times x to the power c is x to the power c, and I have nothing, and I have done nothing here in these two terms. Okay, so now this part. So now we are going to use here a plus b plus c equal to 0 is given, isn't it? So this is our given part, so I am going to use that part here. So it becomes like this, when you use a plus b plus c equal to 0, it has x to the power 0. So x to the power 0 means 1. Any variable or number that have power 0 is 1. Its value is 1. So I have written in place of this is 1. Okay, and x to the power c is as it is, and other parts are also same. And now x to the power b plus c, x to the power b plus c, x to the power c, I have just written the variables first and this number at the last. You can exchange the variables, but you don't have to change their sign. Okay, you are just exchanging their places, so don't change their sign. I have written x plus c in the front and 1 at the back. Okay, I have done nothing here. Similarly, I have just flipped their positions here, but not here. Okay, so now this part is I have just flipped the positions here. And now what you have to do is, again, when you see this part, this first term and second term, you can see that there is same denominator. This denominator of second term and denominator of first term is equal, so we don't have to change anything on the second term, because if you change it, then it becomes different and there is no equal denominator. So only what we have to do is we have to change the denominator of this third term. So again, I told you how to change the denominator. So here is x to the power c and x to the power a. Simple. You have to multiply it with x to the power b. Okay, so because x to the power is not here in this term, so we have to multiply it with x to the power b on the numerator and on the denominator. So it is seen like this. So x to the power b multiplied here, here and here with all the terms in this term. Then you just have to follow the rule. Base same, powers are have to be added like this. And when similarly a plus b, here is a plus b plus c. I have just exchanged their places, but it does not matter where you write, but I have written it in the form a plus b plus c. Here is a and b and c in the power, so I have added it, and x to the power b. So again, we are going to use the property that is given in the question, a plus b plus c equal to 0. So it is x to the power 0, so it becomes x to the power 0 is 1. Then here at this place the value is 1, and I have done nothing else in this area, okay, or in this term. Now again, these two denominators are equal, but it is not equal to these two denominators. So again we have to multiply this term with, here is a plus b, so we have to multiply with x to the power c in the denominator and numerator. Okay, so let's see. X to the power, I have multiplied here on the numerator and denominator with x to the power c. And now you just have to add the powers because the basis is same. So on the numerator it is a plus b plus c. On the denominator, when you add these three, it becomes a plus b plus c. You are just adding the powers, and this is x to the power c, and this is x to the power b plus c. Okay, so now what you are using the formula, you have used the formula a to the power m and a to the power n. When the basis is same, you have added the powers. So again, I have used the formula, or I have used the given part a plus b plus c equal to 0 here on the numerator and on the denominator also. So here on the denominator there is a plus b plus c, so it is 0, so it means x to the power 0 is 1. Similarly here x to the power 0 is 1, and then you get 1 plus this is 1, this is x to the power c, and this is x to the power b plus c. Now if you check the denominators of this term, second term and third term, you can see that there is equal denominator, all have 1, 1, 1, plus x to the power c is all the term, and x to the power b plus c is in all the denominators. So I have just exchanged their places to look them same, that I have written this part in the front. It does not matter you have to write in front or back, but you are not allowed to change their sign, so you have to write with their signs. Okay, so x to the power c plus x plus 1 is at the back, so you can see that their denominator is equal. So now take the LCM. You know how to take the LCM. When all the denominators are equal, the LCM is same. So now the denominators are equal. When we take the LCM, we have to what? We have to add all the numerators, add all these numerators, this and this, because the denominator is equal and the LCM is equal. So this is equal here in the LCM part, this denominator is in the LCM, so we don't have to multiply here, we just have to write it here. Similarly this part, the LCM, the denominator and the LCM is equal, so we don't have to multiply for anything with here. So this is x to the power c here, and this plus 1 is here. Okay, we don't have to multiply with anything. Then see, numerator and denominator are equal, then when we can cancel it and its value is 1, so we have put the value as 1. So you can write here conclusion, hence LHS is equal to RHS. Okay, so this much for this class. I hope you like this video, and if you have not subscribed up to now, so please subscribe it, share with your friends. Thank you.